Okay, so you have like a fraction m on n, you don't know what it is, okay? And you get to say a fraction less than 1, and I add it up and I cancel everything, and I say the numerator, and then you do that again, and you got to figure out what the fraction is. Does that make sense? Okay. So basically, but this was interesting because it came out of like a student came up with a solution, but it didn't quite work, but we fixed it. Yeah. So basically, they said you pick you pick primes P and Q, which are co-prime to M and N, okay? And then you add one on P and one on Q, okay? So if you add one on P, one on Q, you get MQ plus N on NQ, right? And M on N plus one on P equals MP plus N on NP, right?
Yeah.
Okay. And then basically you're told these two things, right? Okay. And you solve them for M and N. Yeah, so it's two equations and two unknowns. Does that make sense? Okay. But what's wrong with that argument? You guys not paying attention. Okay, so basically,
Nothing wrong.
what?
Because if you add one Q, the top doesn't have to be a 1.
It
Or
doesn't.
1P.
No, you get to choose what's on top. Yeah.
I get to choose 1.
Yeah, so you chose 1. But okay, the thing is, I said I picked P and Q co-prime to M and N, right? You're not allowed to do that. Okay. Yeah, so you're not allowed to pick P and Q co-prime to M and N because you don't know what M and N are, yeah? Okay? But if you're allowed to see the results, okay, you can pick any P here, okay? Yeah, so if you can pick any P here, right? And you're given this information. Alright, sorry guys, I'll be 1 sec. So you get this information MP plus N, right? Okay? But the thing is, you don't know if P is co-prime to M and N. So it might also be like M plus N on P, right? Okay? That makes sense? So you don't know if it's that one or this one, okay?
Yeah.
But the thing is, it doesn't matter which one it is, you basically know the size of M and N,
Yeah.
okay? So then you can pick your Q to actually be co-prime, okay? But it's not that you want it to be co-prime, you want the Q to be really big. That makes sense? So if you get Q really big, let's make Q really big by making it capital. So you got M on N plus 1 on Q. It equals MQ plus N on NQ, right? Okay, if you make Q big enough, yeah, then getting this expression is the same as the quotient remainder, yeah? So you know when you do division algorithm, when you divide by a number, there's a unique remainder and there's a unique quotient, yeah? So then you can figure out M and N. Does that make sense? So whatever answer they give you, you just divide it by Q, and the quotient is the M, and the remainder is the N. All right, that's it, guys. Have a good week.
Yay.
Hooray.